we have David Gee. David, say something. Let's make sure this is working. Oh man, I can't hear David. No, I think you muted yourself.
You know why I muted myself, Denny? It's because I was like raving in the background to the music. Sorry about that. So, hey everybody.
Tell everybody where you're coming from.
Where am I coming from? A very cold and miserable and wet UK.
Yeah.
I'm north of London, south of the north.
Nice.
Cheap and happy. Yeah, I can't complain.
We're able to get Dave in here and figure out all this eCam stuff, which is pretty wild. So I don't want to eat up more than an hour of your time. You're our Nats expert. You work over there. You still work over there, right?
Nope.
Oh, you left. I remember him saying that the last time we talked, but you're a Nats guru anyway, so.
Well, I've been using Nats for like almost 10 years at this point. I've been lucky to be on the team for at least, 2 years of that. Still love Nats. I left for my own reasons. I went after a CTO ship, with a small EU firm, which I'm, it's just a different set of opportunities. So I'm still heavily involved in Nats. I'm using Nats in the day job. I've not moved away from that. I'm still all heavily involved in Go as my primary language as well. I just don't happen to work for Synodia anymore, which is life.
It is what it is, but you're the right person to have here. So I want to do two things with you. I want to sort of share what we have right now with Nats. I think it's correct for what we need. So I want to review that. And then I want to get into a deeper conversation about more complicated stuff that I'm sure Nats can do that I don't know if we'll code, but I'd like some background around it. So that's what we're going to do. So I'm going to switch to, we don't need this anymore. I'm going to switch to the code here for a second. All right, you see that, Dave?
Yeah, I'm just struggling a little bit with the screen size, but I can kind of mostly see this.
I don't know if it's, I'll make it a little bit bigger. Maybe that will help.
Yeah, I've tried adjusting my screen, but I can mostly see. Let's just try and make this happen.
So let me briefly tell you what we're doing, show you that code, and then I'll get into the deeper stuff. So we are building basically a chat system, okay, as part of this Ultimate Software series and teaching Kevin all this stuff. And we've actually finished building what I call the CAP, which is the chat access, our client access point. That's what I call it, client access point. So we have to fix our little client, but I got a WebSocket in here. You send a message. It looks to see if the person you're trying to send it to is already connected to this CAP. If they are, great, send it. If not, we throw it out into Nats, and then Nats sends that message to any CAP that is connected to it. That's good. Right now, that's what we want. And then when the CAP gets it, it looks to see if that particular person's connected to it, and if it does, delivers the message. If not, throws it away.
Okay.
As relates to what I need Nats to do right now, I have it set up. I want to make sure this is set up right, but I have it set up so when the CAP connects to Nats, it only asks for any messages that come in after that connection. I don't need old ones right now. And so I want to make sure I've got that setting right. But what I was experiencing was every time the CAP dropped and then connected back, I was getting back all the old messages that I had already received. So I kind of wanted to stop that from happening. That other setting does that, but I feel like that shouldn't have happened if I had acknowledged the message on Nats, which I thought I was doing. And so I want to see a little bit of that. I'm going to show you a little bit of that code to make sure we're doing that right, because I felt like even without the only send me new ones, those messages shouldn't have come back to me, which then has me concerned a little bit about how long those messages stay inside of Nats, right? So those are little conversations, but let's start with, where's all this stuff here?
Is it worth a fundamental conversation first around Nats streams and consumers? So I think there might be a bit of a kind of conflation here.
That could be. Dude, I have the right project now?
USDL, yeah.
Yeah, why am I not seeing? Oh, this is what I'm looking for.
Scoot over this way a little bit. When you talk, you.
Oh, I was over here. All right. So it might be worth that, but let's take a look at this code first, and then I think we'll have to have that conversation. So I'm using the demo system that you gave me, which was great. I loved that. And I've gone ahead and at the beginning we connect to Jetstream. Oh, well,
Yep.
I should say that.
Yeah.
Let's at the really beginning, I connect to NATS, okay? And then I have a subject that Ardan Labs -cap, no big deal. And then we come in here, and then with that connection, I do a Jetstream. Now, in trying to get NAX and AX to work, well, I did this, right? So I did Jetstream, I did an add stream. To get the NAX and the AX working, I had to add this consumer. I've always been confused with the consumer stuff.
Okay.
And then I've got this subscribe sync, which says just deliver new on this subject.
Mm-hmm.
So that piece, I have a question there. And then on the code that retrieves off of bus, listen bus. So I listen, I get a message, I marshal it, I do something with it, and then, oh, was it in here or was it? Oh, it's in here. Where was the call to NAC act, dude?
There.
Oh, here it
Right
is.
there.
Okay, so here I read a message off the subscription, right?
Mm-hmm.
And then I was doing an ACK here. But I don't think that ACK was really working. Because again, if I get rid of the deliver new, I keep getting the old messages back, even the ones that I've sort of ACKed.
Okay. So just on a quick scan, can you just scroll back up for me ever so slightly, like a handful of lines and start? Okay, too many.
Oh, sorry.
So go back down to where you're acking and then scroll up from there. So response, message, fine. See, so you've got your message right. So your subscription. So scroll up a little bit for me.
This is just code that lets me be able to cancel this because this is a synchronous call, right?
All right, let's do the fundamental things first. I think if we get the fundamentals correct, then more of this will make sense. Okay. So a NAT stream. So it's an ordered set of messages. So this is a stream within Jetstream. So Jetstream is like an umbrella set of features. And then in Jetstream, we have the notion of a stream. So it's an ordered set of messages, and those messages can live in memory or on disk. And if we then build a NATS cluster, they can be distributed via the internal Jetstream consensus mechanism, which is over the top of RAF, right? So we have this ordered stream. That's like the kind of primary building block of what a stream is. So again, Jetstream, the umbrella, the stream is one of the kind of components of that. And then what we do to get messages out of the stream, we then attach a consumer to it. So the consumer has like an index, it has a starting point, and it's what you do is you say to the consumer, hey, attach to a stream, and in your case, give me only new messages. And then what you do is you say, now give me a message, and then you acknowledge the message from the consumer that's reading from the stream. So view your stream as like a filing. I thought you was going to have that moment, a filing cabinet, and the data remains in that stream, depending on two things: whether you physically remove the messages from the stream, or number two, whether you have a policy on the stream that will delete messages after a time to live or something like that. So you've got a consumer attaches to the stream, and you consume your messages from the consumer.
Which I'm not doing. I'm doing it from the Jetstream.
Right, so here's the other way to think about this is, and I've seen this a million times, well, not maybe a million might be a little bit of an exaggeration, but let's say if you take the core NATS concepts, so you do a subscription, right? So you go to NATS, and even in the NATS CLI, you do NATS subscribe foo. And then if you publish into foo, That's real time, it's dial tone, it's ephemeral. There is no stream behind that. So when you subscribe, all you're doing is it's like you're picking a phone up and you're listening to a phone call. Once you put the phone down, there's no recording of that. And that's where a lot of this comes apart. So what will happen is some people will be like, well, I've dealt with a message from the subscription. Yeah, okay, great. But it's got nothing to do with the actual stream or the consumer. So when you talk about persistence, you publish into a subject, and what happens is underneath, the stream subscribes to the subjects. And there's two ways you can do this, right? This is where things really get interesting. So you can, again, try this. You can stand up a NAT server locally with a NAT CLI client, and you could do like NATs publish to foo. And if I set a stream up to listen to the subject foo, it will go into the stream in the order that I'm publishing. But I've got no delivery guarantee there, which means I can overwhelm the listener for the stream, again, which is part of the Jetstream family. So then what you do is you do a JS publish, which is a reliable publish. And if, say, in a 3-node cluster, then we need 2 ACKs to basically put that into a stream to have quorum. And then again, we get the consumer, we attach a consumer to the stream, or we consume from the consumer. So where everybody goes wrong on this is they think once you create a stream and you set it up with the subjects, suddenly when you subscribe, it's now backed by stream, and that's just not the case. So you've always got pub sub, which is ephemeral at the top. Then the layer below, when you turn Jetstream on, you have your stream. Then you have the consumer attached to the stream.
Okay.
Make sense?
So, I think so. So on this consumer, this brings back a consumer, right? Which I'm not using, which I should be using.
Mm-hmm.
So let's do this.
So you've got your subscribe sync as well here. So yeah, things get interesting here. So you can attach a consumer and do it this way around.
Yeah. So what is the API set? Let me just call this because I'm having problems here. What is the API set for a consumer then? Stream.
And that's where I always go off to the notes. I don't memorize any of this stuff. I'm terrible.
All right. Because I can subscribe sync here, but there is no sort of subscribe at a consumer level.
Yeah, so what you do, remember the subscribe language is core pub sub. So when you have a consumer, you consume from it. So what you're essentially doing is you're doing like next message or, kind of get a message. So there's 2 or 3 ways of doing this. You can have your consumer where you give it a callback. So every time there's something comes in, it will pop a message into the callback, and that will deal with it. And I'm just looking now. You can do a consumer, a fetch, or a fetch no wait. I'm assuming you've got like IntelliSense and everything in there. So if you hit const, so then you've got, let's have a look. Do you have any fetch in there? Pending stream. Add consumer. Let's have a look. I'm just looking on NATS by example right now. Create or update consumer. So can I?
It's weird because I don't see a API set for the consumer.
Also
Just
thinking.
consumer info.
Yeah.
Yeah. So this is just consumer information, right?
Just have to think about this. Can you scroll up a little bit for me? So above line 63, you've added the stream, fine. You've got your stream config, you've got your subject that you're subscribing to, and you're happy that the messages are going into the stream correctly, because when you run this thing, then you get all the messages, not just any messages, right?
Yeah, that was working.
Yeah. Okay. And what you can do then, let's have a look. So NATS by example has got some really good examples of this stuff. I never remember this stuff. I always have to go back to basics and go back to the docs. I have got some lying around though. So once you've got your stream, you've added the stream, and then with the stream, you can then add a consumer. So on line 55, you've got add stream.
Yeah.
Take the underscore away and call it, I don't know, stream 1 or something.
Okay. Stream info.
Well, that will be your stream. So if you just, yeah. All right. So you can leave it whatever you want, but maybe just call it stream 1 or something like that, because that's effectively your local object. Then you can do S1, and you should be able to do S1 dot create or add consumer. So if you just type in CR, and see what happens there.
I don't know. It's weird.
That's weird.
Because this is info. It's like information about the stream, not the stream itself.
Oh, wait, you've added stream. Do create stream.
Okay.
And then
I don't have a create stream there.
weird. Okay, I know what you're doing here. This is some of the old style setup. Oh, man. All right. We're going to unpick some of this. Right, so line 48.
Yeah.
I'm just going to assume you've got all this backed up, right?
Yeah, I have everything. We can,
Okay. So on here, so remove that text and then type in jetstream.new. So remove con, you don't need that. So jetstream.new.
Oh, as a package name.
Yeah, and then drop in your NATS connection. So just con should be fine.
Okay.
And then out of that, you'll get your Jetstream, so JS error, fine, handle the error. And then you can do js.createStream.
Okay, damn it. Type, man, type. All right, so as usual, Go Please doesn't want to find imports. So let's assume then that this is going to be here.
You know what, I should have come prepared for this, shouldn't I? Let me open up existing project and I can follow along with my own code.
Yeah, because it's not finding, but I can look that up too.
I think some of this will make sense once we get the kind of chickens in a line, or ducks in a line or whatever. This is good. We're on to something, so
all right.
all good.
Having the word Jetstream here was right. We might just have to do it tidy. Okay. Fix that problem.
Cool, right. Give me 1 sec. I'm just pulling out some of my previously known works.
Okay. Then JS dot. From there, I can do the add stream.
Yeah, so once you have your JS, you should be able to do, let's have a look with this, js.createStream.
Yeah.
Boom.
Okay.
Then you can pass in a stream config, so your subscription, so what the stream is listening to. Give it a name, then you've got your subject, which you've already got in there.
All right. Create a stream, given a context. Ooh, I don't have a context right here on new. So let me just do this for now. So I figure out what I want to do there.
Yep.
And then this takes a...
Oh yeah, I think it's a function. You might want to... Oh no, is it? I can't. There we go.
Semantics, which was good. Okay.
Yep. So and then now you've got your S1.
Yeah.
And then from there, you should be able to do a create or update consumer.
Create or update. Yep.
Ta-da.
Okay. And then this is where I had all this instead of the add. We had to create. Now, I had durable here before, and we had the act policy. But this now, I'm guessing, takes a Jetstream act. So if I say act explicit, that means I have to do the act. Okay.
Yep.
And then
you go on,
this
sorry.
returns a consumer. right?
Mm-hmm. It will receive, yeah, it will give you a consumer and an error, of course.
Right. Dude, I feel like I'm having a stroke right now.
I'm not going to laugh about that. The world's crazy.
Okay, and now after this, I have a consumer.
Yep. But it will consume from the beginning unless you put a policy on the consumer to only give you new.
And now, I see. And now I use the consumer and I can give it a function. Okay, so I'm not going to be using this subscriber thing anymore.
Yeah, so line 76 to whatever it is, 79, you can probably get rid of.
All right, so let me change this to be the consumer. And then I don't need any of this. And then C1 is the consumer. And the Jetstream, stream. I guess these are all interfaces. Okay. The Jetstream stream. Oh, we could have just. Oh, we called that new stream. Yeah.
So in your consumer config, if you can add the line deliver policy. Yeah. And then you want policy new. New policy.
Okay.
There you go. That should mean when the consumer connects up, it will basically carry on.
But if
And then because it's durable.
if I do these acts right, then one would argue I don't need this because I won't get the same messages twice.
Right. So if you let's think about this from a Genesis perspective. So everything's fresh, nothing's in the cache, disk is empty, brand new chat app, no users, but you're going to build it and make millions or billions of dollars. Right. So we start off, and then somebody joins, starts putting messages in there. When you acknowledge the message on the consumer, from that point onwards, even if, and you've got a durable, so let's say the world restarts, NATS comes back online, the state of the consumer is stored as well as the state of the stream. In theory, you're already up to date. But then let's say, I don't know, something hellish has gone wrong and you don't know where you went. Then you can add another consumer and you could say, now only give me things that are new to the stream. So from a Genesis point of view, if you're happy that you can manage a state all the way through, then acknowledging that will push the consumer index forward. But if you add a new consumer, because you can have more than one consumer to a stream, you could literally say, deliver me only new, and that should do it.
This is for this connection, because I need this message to go to anything that's connected to NATS for this stream and subject. I want it to receive that message, which I was getting before. So if I have 4 of these caps connected to NATS, I want all 4 of them. Well, let's just say for now, 4 of them to get the message.
So think about this. So for each cap, then you're adding a consumer. That's the model here. So this thing stands up. New cap comes online. You add the consumer.
Yes, so this is going to happen for every cap that connects to NATS. It will do new.
So every time a cap comes online, then the consumer is going to start right at the back of the stream. It's going to start from the top. Because when you do an acknowledge, it's only for the consumer, not for the stream. The stream, again, is a static list of stuff.
Yeah, it has to be just the ACK has to be at a consumer level.
Yeah.
Yeah.
So if you want a new cap to come online and receive the entire contents of the stream, then this is fine. And maybe that's what you want, obviously, to play the catch up when a cap comes online. But if you don't want that, then you can uncomment line 67.
Okay. But I still need to do ACKs?
So this is where you can have I think it's a sync consumer, where you basically give it a callback. So every time a message comes in from the consumer, your code deals with it and then it's automatically acts. But with the consumer that you got here, then you're going to have to, I think, act the message when the message comes in.
I like the idea of acting the message, because if I shut down right in between getting the message and doing something with it, right, I would have acted already and it would have gotten lost. So I like the idea of acting it. The problem is when it's deliver new policy and I restart, I'm not going to see it then anyway. Because I'm going to say, only just give me new stuff. You see what I'm saying? But let's try this for a second. Let's keep going down this path here. So we did new, I'm just creating a background thing. We create a stream. I attach a consumer to that. I'm going to do this policy. I'm now keeping the consumer in the subject. So before with read message bus, the idea was I was blocked here waiting for a message to come in. Now, what it seems like now is that consumer dot.
You can do consume.
I would do consume, which is going to handle all of the. Now, what if I wanted to do this synchronously here?
Then you're going to want fetch, and you can do fetch with no wait. Let's have a look.
So this is it here.
Code.
Next is user retrieve the next message, method with block. So this is really what I want now. If I'm keeping this sort of the same. So it would be nice to have a next with context.
This is, I think, where we have the fetch or fetch bytes, and somewhere I have got a pattern for this where I literally feed a timeout or a timed context.
Yeah. Because the fetch, I really just want to do a next, just to keep this pattern that I have here. But next only takes fetch options, which I don't know. You know what I hate is like to see the options. There's no like clean way in IntelliSense to see what options are fetch options.
Yeah, and a lot of this changed as well, which is,
but
kind of interesting.
Saying that I don't need fetch options, what's a bummer here is that they didn't. Or so maybe there's a fetch option for a timeout.
Right, I have an example of that. Let me just jump on my GitHub account. So there was a change, I think, back in 2.10, late 2.10, where there was like a Jetstream kind of refactor, where pull consumers are now the preferred way of doing things, and they almost became kind of like the default. I'm just trying to find that. I've got some examples. Like all good things, I probably called it new_new something new.
Wait, right? But it's kind of not what I want so much as a. Yeah, it just stinks that they didn't support context on this call. Now, particularly, I don't particularly care, I guess, because that will fail anyway on a socket connection. So I think this will be fine, but it just sucks not having context support. Now this is a Jetstream message, and it's not pointer semantics anymore because it's an interface. Everything went interface crazy. All right, let's just assume that would work. We're going to find out. So that just keeps my logic here instead of using the handler, which I could switch to on another show or something. The last piece was this, which was now, because now this gave me a Jetstream message. And it looks like a Jetstream message has data, because everything is an interface. Okay. So that should work for that. What's the last thing? Okay, publishing then.
Yep.
Do I now publish on the Jetstream?
Yes, you want to use a JS publish. That gives you a delivery guarantee, or you've got basically a quality of service, not to be confused with network quality of service, because that would be mad, but it gives you a delivery guarantee
on the
Jetstream
stream.
Yeah, so what happens if we think about this in fundamentals?
Yeah.
When you do a Jetstream publish, and let's say you have a 3-node cluster, the stream will listen to the publish, and then it will, when it gets say 2 out of 3 responses or writes to the streams on the cluster, then it comes back and then basically tells you it's now basically in the quorum. It's been accepted by the cluster. So in theory it's safe, but there is nothing stopping you from doing a vanilla Kubernetes publish. So you could do like a con.publish, publish, and the stream will still populate from that, but that's known to basically just not very reliable, right? Because Kubernetes is massively performant, like tens of billion messages a second, and Jetstream's just not that fast. So you will get missed messages at some point as performance ramps up. So when you do a Jetstream publish, you're getting guaranteed delivery into the stream.
Okay. So essentially, okay. All right. So context, which I'm going to just pass a context. See, it's funny. This has a context. This has a subject. This has the payload. So all that's there now. Which means I need a context for sending this here, which I have now there. Okay. Everything is brown again. So I'm creating a Jetstream and I'm saving that because I need that to publish. I create a stream. I need the S1 variable for my first stream because I need that to create or update a consumer. And the consumer I got to keep.
Mm-hmm.
Okay. Now, listen bus blocks on this function, waiting for a message to come in. If I get it, I do all my stuff. Everything's okay. Read message bus now is using next on the consumer. And this time, I do the message ACK, which means I don't get it again. And
just scroll up for me. I just saw something that I just couldn't quite get my head around it. So you're doing a message consume next. Fine. You're then passing the message into a channel, and then you're acknowledging the message by the channel receiver. Yeah. Okay.
Yeah, but if we get here, that means that there wasn't an error and it wasn't a timeout.
You've got sorry, Bill. You've got a response. You've got resp.message.ack. So, okay, that's the channel. Sorry, yeah. My bad. All right, that's what I was missing. I just couldn't see. Sorry, the screen I'm looking at is about this big. So I'm like squinting like crazy.
I'm sorry, it's so small for you.
That's okay. I would move closer, but I think anybody watching this is going to be terrified as my face gets bigger as it moves into the screen. There we go. It's like
crazy to put context there for cancellation. Okay, and then we do the regular publish that we had with the context. So, okay, Kevin, we're gonna try something now.
Okay.
I'm gonna leave the deliver new policy off. The little client I have is really bad, so don't judge. Okay, we're gonna see if we can get a message back and forth again.
Okay.
And then we're gonna see if the ACK works. Maybe we can use, remember hack?
Yeah.
Oh, but that hack program's no longer valid. I'm gonna get rid of hack.
That's all changed now.
Yeah, we changed it. So what I'm gonna do is we'll each run our own local cap. We'll just see if we can do a message back and forth again to each
Okay.
other. Then I'm gonna shut down the cap and turn it back on. And we shouldn't see the message again like we were last time.
Yeah.
And if we don't, then we know the ACK is working because that was already sort of delivered,
Okay.
which is cool. Okay. Let's see if we can get this to work, and then I've got other fun things for you.
Well, there's one more thing. The durable consumers live on the NAT server. So for every cap that you have, you might want a different durable consumer name. Else what's going to happen is they're all going to use the same name consumer, which means when a new cap comes online, you gain the inherent behavior of only new messages are seen. But what you're probably going to see is when you stand up multiple caps, you're not going to see the previous messages because as far as a consumer is concerned, it's up to date. You've done all the next messages, you've done all the consumes. So you might need to...
Cap needs a different...
Yes, a different consumer name for the durable name.
So this name can't be the same. Okay.
And all that will happen is all of them will use the same one, which is really going to confuse you.
Because then not everybody will get the message because somebody's already acted
Yep.
out of this consumer.
Yep.
Okay.
So the idea is that when I do the publish, I'm publishing to all, when I do this publish call down here, hold on. Here. When I do this publish call, and I publish it against this subject, Nats is sending it to all consumers.
No, it's sending it to the stream.
Okay.
The stream is listening to the subject,
Okay.
and then the consumers consume from the stream.
So all consumers will get this message from the stream.
Yes.
As long
And then
as
each
they
cap
all
has
have-
to acknowledge to their end consumer.
But for that to work, each, for that to work, they all can't be using the same consumer name.
A little bit of config may be required here. Give it an ID, whatever, your cap ID, and then make that the consumer ID. And at that, you should be good.
Okay. The
I
question,
can see you're so happy about this.
I mean, this is what it is, right? But
Yeah.
what I'm paused about is the same cap should restart with the same ID, right?
This is why I think a config item is probably good. So if you could have like a small config blob, whether it's an mvar, whatever, cap 1, cap 2, cap 3, and then make your durable consumer, whatever, 1, 2, 3, and pin it to the cap name, and then you should be good at that.
No, it just sucks because everybody's got to configure but okay, let's say that we solve that problem for whatever reason. Since I'm using the demo system, when I don't run this in 3 months, what remains in the demo system? The stream and these consumers? Consumers, in other words, should I be disconnecting or deleting consumers?
You can you can delete it within your exit routine, or you can just grab the NAT CLI client and just delete them as and when.
But I don't even see an option for deleting the consumer. Oh, delete consumer here. So just for this demo then, I think what we can do is, I don't want to get into a whole config for what I'm doing. That takes it to another level. So we could just generate a unique ID, and then on shutdown, we'll just delete the consumer. Just keep that clean. So every time you come up, because again, from my perspective, you only really need new anyway. I just want to test this ACK, but you really only need new stuff, the way we're building things. And I'm going to talk to him a little bit more. But if we delete it, then I feel better about a unique ID here.
Got it. Okay.
That works,
Yeah,
I think.
it will. So we got to do a couple things then. So what we can do then is just say UID new string, right? Can this durable thing be anything like a UUID?
Yeah, UUID should be fine. Probably avoid dots and right-hand chevrons. Other than that, you should be good.
Okay. So if we generate this unique ID, okay, then what I'm going to need to do here is save the ID. All right. And where did I put that in the list after JS? After JS, consumer ID. Okay. So I saved the ID, right? Okay. Stop trying to help me. Now the problem here is I will need a chat just called shutdown, right? Where, and given a context, I can do a delete consumer where the consumer is c.id. This way I don't have to get into this. Now, in order to do that, I need to save the stream itself. So we've got a jet stream. We've got a stream. Then we got a consumer. A jet stream, got a stream. Then we got a consumer. All right. And, you know, we can, I don't really care if there's an error, but we can just do this for now. Okay. So there's a shutdown, right? Shutdown, that just cleans up the chat system. Whatever. Oh my God, dude. Okay. So what that means now, if I come back here, after chat, we'll do a defer chat shutdown. And it needs a context, which right now we'll just give it a background context, or let's do it to do because I don't know what I'm going to do with this just yet. All right, which is fine. So that now, what that will do is eliminate any config that we need. So you'll come up with a new, where are we? Oh, here. Okay, here. So we'll come up with a new ID. Everybody will have their unique ID. And then when we shut down, that just gets deleted.
Got it.
And
Okay.
then we're fine for what we're doing. Again, we really do want to deliver new policy. I just want to see if the acts are working now or not. Then when we fix the client, we'll try 3 of these and make sure all that's working. But I think I understand this now. Okay, so let's add this.
Yep.
Okay, commit minus AM. Okay, new nats code. I'm gonna push that. Okay. I'm gonna come back.
You're not even doing branch-based. Man, brave.
Oh, dude, this is like a class. I'm just pushed to main, man. Oh my God.
I love it.
This
It's okay.
isn't
I'm going
like
to take
going
under
into
it.
production or anything. Okay, so what's our make command to start this thing again? It's called
It's,
chat run, right? Make chat run. So a bunch of messages just came in off the stream
From last time.
from last time. Okay, so I'm gonna hit, so hopefully we had acknowledged those this time, right? So I just tried to shut down. Nats consumer deleted. Type jetstream is error. Okay, let's take a look at this.
consumer deleted.
Because I think we got a new type now for something. Okay, so I was trying to shut down. Sorry, yeah, I gotta look at this real quick. Is critical error.
Mm-hmm.
So we came in here. So this time we have a new sort of error now that just showed up. It's this. And if this is it, it is a critical error, right?
Mm-hmm.
Okay. And my guess is that oh, damn, that is an unexported type. So that's not fun. That means I can't do this. What did I see here? Error. Yeah. Okay, well, I don't know why. Oh, so we have an order, like we deleted that first when we were coming down. That's something else. But that's a bummer to me that that's unexported, because what that tells me then is that I can't do what I want to do here, right?
Yeah, I understand that.
Okay, so I gotta get rid of this for that. This happened because when we were shutting down, we deleted the consumer, but other things hadn't been shut down yet. Remember, we have orphan go routines that we've sort of agreed to, right?
Yeah.
So for me, that's fine. But I'm just bummed out a little bit here, because if I do jetstream dot,
If you type ERR, it'll just shortcut you to the list of errors.
Consumer deleted.
so that's what we ended up getting. We got a consumer deleted. So, so I don't think this is well, actually that is important, because essentially if that happens, it is a critical error, right? So let's just be smart about it. Okay, we'll add it this way, which is fine. Okay, so now let me bring it back up. No, you see, we got all the messages again.
You would do, but you've got a consumer with a different ID.
Oh.
And you deleted the consumer. So this is what I'm saying about persistence and durability and all this kind of stuff, which means a new cap, all the messages.
So let me try this then, based on what you're saying. If I don't generate a unique, if I just take one, let's just do UUID generator. Okay, copy this one. So if I do this, right, that will be the same. Now,
And then don't delete the consumer.
don't delete it. Okay.
Nope, because when you reattach, you're re-invoking it with fresh memory and it will index from 0.
But when do all the messages finally go away from the stream? Can you
In the
set
stream,
a policy that they only can last for 24 hours?
Yeah, you can put a TTL on the stream for 24 hours, for an hour, whatever.
Right here.
You can put a size on there. You can put a policy on number of messages in the stream. You can put messages per subject. It's quite flexible.
But that's on the create stream side.
Yes.
All right. So like a time to live, or
I think it... Oh, what is it called? Let's have a look.
the max age is the
max age of
maximum
the
age the message will. So it must be max age.
Yeah, so I'm just looking now on my project.
Message.
Yeah, I think it's max age. That makes sense. All right. Let's just say max age. Yeah, 24 hours, right? Okay, so I'm not going to delete it. We're going to try this again. So we'll see it again. I got a new one. Oh,
Stream name already in use.
Okay, now I'm getting stream name, Nats add Jetstream.
Yeah. So when you create, again, you've got
I gotta
a
delete it because I changed it. I remember that from this other project.
Oh,
Yeah, remember the, yeah, that's all fine. I'm just gonna delete it.
what you had commented there.
Yeah, that's why I had that there. Okay. Okay, good. Just... Okay, but this time I got no messages at all.
But you also just deleted the stream, so there's no messages in there, I don't think, unless you've got something generating messages in the background.
Okay, so let's do this. Make... Don't bring up your thing yet, Kevin. Because this is the next thing we're going to talk about. Okay, so I just sent 2 messages, hello, through, right? Okay, so I'm going to do that. I'm going to restart it. Didn't come back. Okay, so that solves that problem, which is cool. Okay, which is bad and cool at the same time. Because now anybody that downloads this needs to, so we're gonna write a little code that writes a file with this ID in it, so nobody has to configure this thing.
Okay.
Okay, so we're gonna have to do that. That solves that problem. Okay, I can code all this. Oh, we gotta see if it works though. See, now you need a new ID. It's a freaking problem. Okay, let me.
You need a push.
Yeah. You're gonna have to hack on that. And then if this works, I have one more thing for Dave. ID stuff. Okay, pull that down, Kevin, and go into the code and go to line 69 and just get a new.
Let's see.
Did you
Hopefully
do
I
a
have
git
it.
pull?
I did. Yeah, my code.
So go back, do a git pull. No, what are you doing?
I did a git pull already. I have it.
Oh, okay.
Yeah, yeah.
So open up the browser and I
Where
didn't.
you at?
You got to go to line 65. 9. There it is. All right, go open up your browser and get a UUID. I just want to, if I hack this test, I can code the rest of what I want. But I have one more question for you.
Sure.
But I just want to make sure that, yeah, dude, copy that. Okay.
Okay.
I'm gonna run the cap.
You want me to run too?
Yeah, run your cap. You run hack 0. I mean, you run hack 1.
You did 0. I'm doing 1.
All right, do 1. Send me a message. I got it back. Okay, so all that is still working. You got it back.
Yeah.
Okay. Okay. All that code is still working. So that's good. And now if you kill your cap and restart it, you shouldn't see any old messages. And you don't. Okay, kill
No
your
old
cap.
messages.
Okay, now, David, here's the next thing. Are you ready? This is the
I'm
last
ready.
thing, last thing
Bring
I
it.
really need for you. Is there a way to configure the publish? Is there a way to configure the publish so I don't get back my own message?
Split horizon, that old bag.
You see what I'm saying? Like, there's no reason to send it to me because I don't need it. I'm trying to feed
Yes.
other people.
So on your let's have a think about this. On the consumer, you can filter out users. I'm just trying to figure if that's positive or negative logic, but you can do consumer filtering. Let me just have a think. And a Google. I might need to go
Now
into
I understand what a
the Nat
consumer
stocks.
is. Now I understand what a consumer is to a stream. Because each consumer allows an individual to consume the stream independent of each other,
Got it. Okay.
right?
Yeah.
Right, as opposed to all of us working on the same consumer. That's why it needs a unique ID.
Okay.
And this is why all the different caps can get messages out of that stream and then manage where they are in the stream.
Because each person is a consumer. Each
Yeah,
person.
the way I'm going to think of it is we publish a message to the stream, right? And it's going to go to this, and it looks for all the consumers attached to that, and it goes, and then you can, right, you get your own private copy of that stream to process as you see fit.
Yeah.
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 So that was the piece we were missing. So we're not going to do a shutdown here because we're going to have to code this other thing, which also now means that you should undo your changes.
Well, next time I pull, it'll be gone.
No, you have to undo them or you'll get merge conflicts and stuff. So just, you can go into VS Code undo. All right. So the next thing then is, all right, once we're done with Dave, we're going to write a little program that writes to the ZAR folder. Oh, under chat, we'll have a ZAR folder that writes that ID to a file.
Okay, and then it'll basically
That way,
use
anybody
that,
on the stream is running this, they'll get an ID.
and everyone will have a
unique.
different.
And you don't have to worry about configuring because somebody's going to forget to do that, and then it's chaos. Then we don't have to delete it. The nice thing is now, from our perspective though, I still think you want to do this because remember caps come up before clients.
Yeah.
So when a cap comes up before, what am I doing here? Oh, I hit the wrong button. I'm just going to switch our view. Oh. When a cap comes up before a client, the cap just got all the messages. There's no clients. So what's going to happen? They're going to throw them away. So at some point, if we wanted to go next level,
Yeah.
right, you wouldn't want to necessarily, you'd almost have to have your own little internal queue in the cap waiting to see for 24 hours if that user ever connects.
Okay.
You know what I'm saying?
Yeah, and if they don't, then
Because then it's like when you got off the, when you finally got signal on the plane, iMessage starts sending you messages,
yeah.
you know, right? It's like we won't have that support right now. Because the moment we connect, we get everything, and we're like, you're not here, you're not here, you're not here. You'd have to deal with that at another level.
Got it.
So
Okay.
I think it's fine to have this. And I think it's good to keep the ACK in there anyway, but it doesn't make sense. Like that's what makes sense for what we're doing. But I know it works now, so we're fine there. This isn't critically important, Dave. It was just like, I thought if it was like quick, that Nats knew that this connection sent this message, so you don't have to put it in their consumer.
Yeah, because I think if you keep the mental model where the streams and the consumers are separate and anything irrelevant of source being published basically being published into the stream, I think the logic has to be, if you don't want it on the stream, don't publish it. So therefore, some of the split horizon thinking is different. So what you might have to do here is publish, do a JS publish.
Right.
So I think it's just mega lag on this. Sorry, Bill, I'm not trying to interrupt you, mate.
No, that's good. I'm the one that's off here.
And the best thing to do is in your client, so the one that's attached to the consumer pulling the messages in the message, I don't know, I've not seen the message format. You could add basically just a filter. If it's me, don't echo it kind of thing.
Yeah. Okay, that's what I was going to code. But I wasn't sure if I got that for free. So
have a look at the filter subjects on the consumer. That's probably the best, but I don't think you can just negate one thing. What you might be able to do is transform it to something else. So like, throw it in the bin or, whatever. So grab anything from Bill and dev knowledge kind of thing. You might be able to do something like that.
What I'm going to be able to do now is this. Because I now have to have an ID for the consumer. So therefore I'll have a cap ID. And then if a message comes in and it matches our cap, just ignore it.
Got it. Okay.
and then we're done. I just didn't know if we got it for free from Nats, but now we're gonna have we'll code that, and that will solve that other problem. We'll just ignore it. Okay, so Dave, this was brilliant because we would not have gotten here without you. I think we better understand this now.
Yeah.
We'll still do the new anyway for what our purposes are, but later on, if we wanted to be able to have that delivery within 24 hours, we'd have to do, the cap would have to maintain something too, right?
Yeah.
To do that. But that's okay, right? So this is good. Now, just before I have you sign off, Nats, and I'm not installing this, but this is for a bigger conversation I'm going to have with the stream later. Nats, a Nats Jetstream instance can connect to another one, right? So you could create this universe of sort of Nats systems that messages can fly all over the place, correct?
Yeah, there's some basic rules, but yes, in principle. So Jetstream, if we think about just, there's like a blob, and the blob is Nats. Within that blob, Jetstream is just one tier of functionality. So Jetstream, when you enable it, when you turn it on, it has its consensus algorithm internally. And for that consensus algorithm, you need an odd number of nodes. So Jetstream can run on one node. It can run on 3 nodes, 5 nodes, 7 nodes, 9 nodes, all the usual crap. And there is a tremendous amount of clustering flexibility. So for instance, you could have like a 3-node cluster clustered with another 3-node cluster, clustered with a 3-node cluster. And, this AI stuff, I hate it. Anyway, balloons. So yeah, you can have these islands of clusters connected together, and that would be a super cluster. You can have a stretch cluster. So we have a normal cluster stretched around the globe. But then things get really, there's only really a swear word I can think of this, but they just get, let me rephrase, bat poo crazy.
Bat poo.
Bat poo crazy. So you have like a cluster, and then what you can do, you can have these things called leaf nodes, and the leaf nodes can attach to the clusters. And then things get really interesting, because then you now have a security boundary and an account boundary, which means a leaf node is a fully functional NAT server remoted into a cluster. And if you bind and share on the account, then you can have islands of Jetstream within one cluster, right? So you could have your own streams and your own consumers on a leaf node, maybe feeding off a stream somewhere else.
So
and then what? Go on.
One of the things I want to talk about that we're not going to do on this, in this particular problem here, right, is everything I'm trying to do, I want to try to maintain a level of not just distributed, but decentralization, right? Mm-hmm. So I could make an argument right now that Nats has sort of centralized us because somebody has to own this Nats, I'll call it fabric, right? Somebody has to run that and own that. And if Nats goes down, everything goes down. However, I can make the argument that not only can people run their own cap, which is the chat that talks to the Nats, we could also technically have people run their own Nats as well and have those Nats connect to each other. And so technically this could be decentralized as long as we allowed people to not just run their own caps, but also run their own Nats, where those Nats could be connected to each other. And then if one person decided they don't want to play anymore or pay for it, and they bring their Nats down, I could use my cap to connect to a different sort of Nats that's out there. But basically create a network using Nats as the ether,
yeah.
Right?
So logically, this is, I always try and just keep things simple. Nats is one of these things, I think I've said this before on a podcast as well, that you start off incredibly simple. We've now got pub/sub across everything. Brilliant. And then you get to the next footstep and then run headfirst into a brick wall, and, bad things happen. So what you have to do is, absolutely the craziest bat poo diarrhea you've ever seen in your life. But it is immensely powerful when you get it right. So where I would start with this is
I'm not going to try to do it, Dave. I'm not going to try.
Oh, don't worry. I'll explain it.
Theoretically, you could do it, though. Explain it. But theoretically, you can do what I said. Okay.
Oh, more than theoretically. I mean, I do this with my own crappy, SaaS products, and for the, even for my new day job with, I'm field CTO for this company in Germany. The easiest way to do it is have a central cluster, minimum 3 nodes. You can geographically put them. I mean, my own cluster, for instance, I've got 2 nodes in Germany, 1 in France. Latency is beautiful between them, and if a meteorite hits one of them, I'm going to survive, right? 2 out of 3 is good, fine. I don't know why anybody wanted to use my services when meteorite hits, but let's just pretend they do. And then what you could do, let's say if you had a 3-node cluster that is like cap global, whatever, and you pay somebody $1 a month to access that, you could stand up your own local cap, which then Leaf Node remotes into global. So the actual chat stream is hosted on global, but then your local cap with your own consumers and all that stuff can connect into the global service. That way, then you can maintain some local state, and you've got your remote state, which is your kind of, system of record, your source of truth, and all that kind of thing. Where things get really bad, and don't ever do this, is when you start doing peer-to-peer NATS leaf nodes, because you're just going to break stuff. You're going to get to a beautiful balance where you've got 3 nodes, 5 nodes, then stuff goes wrong, and it's just like, don't do it. Centralized cluster, leaf node in, and that way then you can almost cellularly scale the thing out horizontally, just keep adding caps. And obviously then it's only resources, network throughput, CPU, memory, disk, where you begin to have problems. But that's the easiest way of making this thing.
Perfect. Because I want to keep this architecture we're building technically to be really decentralized, right? Like no one owns any major piece of what we're doing. So
Yeah.
we have NATs clustered together, and somebody wants to shut down their NATs, the network still functions, right? So a community of people could do that if they wanted to. All right, I'm not going to take up any more of your time because I know it's late over there. You solved all my problems, which is beautiful. I knew you would. I appreciate it. If anybody has questions for Dave, I even know Dave's not doing NATs anymore professionally. You send them to me, and then I'll talk to Dave. So bill@ardanlabs.com, and I'll filter them over to Dave. Dave doesn't need NATS questions anymore. But, dude, I appreciate your time, man. This was brilliant.
No, always. I'm happy to come back, obviously, if I'm not being too much of a pain in the behind.
And I'm going to see you this year at GopherCon UK, right? You're going to be there?
You will. I'll be there, yeah.
But I saw
with
you
my
last
new
year
white
in
glasses.
EU, so you're going to go to Berlin too? Maybe I'll see you in both.
Maybe. Yep, absolutely. I'll certainly be at London, hopefully be in Berlin.
Brilliant. All right.
Awesome.
We're going to say goodbye. I appreciate your time, and I'll chat with you again tomorrow. Just thank you one more time.
This was fun, by the way, so thank you for the invite. Really cool.
Awesome. All right.
Awesome.
Okay, so that means that we can take Dave out of our thing here. Okay, good. So, Kevin, we got a tiny bit of work to do now.
Yeah.
We have a properly configured NATS thing. What scares me is we had it work, quote unquote, working,
Yeah. We
right?
did.
Even just the way it did, but without the consumer, it never really was going to work the way we thought it was going to work.
On a scale of any.
No, because we were all consuming the same.
Yeah.
And because the acts weren't working, because acts wasn't working, it all worked because every time somebody connected, it just went. So I'm going to keep this, but we have to solve this problem. Okay.
Yeah.
So what I'm going to do is the following. Remember, we're working inside of chat here, right? Each
Yep.
one. I'm going to add a folder called Zarf. And under Zarf, I'm going to add a folder called, I don't know, ID. I'd rather have folders than just raw sort of files there. Okay?
Zarf is my favorite of all the.
Do you know
of
there's
all
a
the
project
directories.
now called Zarf, man?
Is there
Somebody
really?
needs it. I mean, it was a good name for what they're doing. If you don't know what Zarf is, you got to look it up. Okay, so here's what we're going to do. We have a couple things now. You know, this takes a context now, but ideally, I don't like the idea of passing a context into new.
Mm-hmm.
You know, so that to me is a smell. When I have to do this inside of a function like this, right? It's kind of a smell because the whole point here is that if I can't do it, we can cancel it. I mean, that's why it's taking a context. Now, what are the things that we have to keep? We have to keep a jet stream, a stream, and a consumer, right?
Yeah.
So what this tells me then, I'm wondering if we should pass the jet stream in because then we can deal with an error. But we're already using it in main, right? So I go back to this. Let's go back to main for a second because I keep struggling with this, right? We did the NATS connection here, and then we did the chat, which is what is now potentially failing with, with the need, let's say, for context or not. But now if we look at this chat thing, ideally, if we just asked for the jet stream, that would be enough too. But why should they know that they need a jet stream? I think this has to sort of stay here. And, we could say here that this should take so many seconds, but we know it's going to fail pretty quickly if things are bad. So let's just leave it like this for now. I think that's fine. Sometimes when you're not sure what you want to do with context, you can use a to-do. That's why they did that. It's the same thing as background, but it kind of goes back to, do we want to do this? Do we want to, so let's just do a to-do here because I'm not sure what we're going to do there yet. So this is good. This is, so NATS, we can call this new jet stream. This is NATS create jet stream. This is NATS create consumer. I'll just call it create consumer. And then you have this. Okay, we got to solve this problem now. So ideally, we're just going to write this to the Zarf folder. All right, Zarf ID folder. But we need to see if one exists already. And what we could do, there's a couple ways we can do this, man. We could create a file where the name of the file is the UUID.
Okay.
Right? We could just create an ID file. So maybe we just under Zarf have an ID file. So let's do the following. Which would now mean that I need another sort of, let's do it this way instead. I think it will be better.
Pass it in.
Yeah. Question is, should we make it a UUID or just a string at this level? Let's just pass it in and just make it a string, okay?
Okay.
So this assumes now that you're gonna give it an ID. And that ID we're gonna save. And now we have the ID for the cap ID, right? In fact, we can call this the cap ID just to stay a little bit nicer here. Okay. Now what I want to do is when we publish a message right here, the cap ID is c.capID. Cool, right? Now, we made the cap ID a UUID, but I think we're going to have to keep it a string.
How come? Why couldn't we use a UUID?
Because I think you're setting too strong of a policy. So now we're getting into policy questions.
Okay.
Do we want to restrict the user of chat, which is still at our app level, so we could, that this has to be a UUID, or should we allow it to be anything? So let's say that this isn't a foundational package, right? If it was a foundational package, then I would say maybe we make it a string. But let's say that we go in your direction, okay? So UID.UID, fine. We use a type instead of just an empty string that can be anything. Here we can just say string, so that comes over the wire that way. Now, one could argue that, yeah, durability takes a string, so that's fine. All right, and then what we have here on, I need to publish again, send.
There.
All right, so now we're going to publish this cap ID, right? So now what happens here? Read message bus, next consumer. It's not an error, right? We acknowledge. Now the question could be this simple. If, oh, we haven't unmarshaled it here yet, have we? So it's not to do here. It's
We
to
do
do
that
here.
in listen.
Yeah, we do it here. This is the point where we would have to do it. So if that equals the same cap ID, then we just want to do a continue. Like, I don't even want to see it in the log. It's noise, right? Just want to throw it away.
Got it. Okay.
That way we just throw away our own messages. We still got to unmarshal it, unfortunately, but we won't see in the log this and user not found and stuff because we know that we just got it back. So that will solve our cap ID issue there. But we now have to generate a unique ID.
Mm-hmm.
So I think we can do that here. Now, what we can do is ID path, string, and default this to
Inside Zarf.
yeah, there. So we make that the ID path just right inside of Zarf, right? Because we always run this stuff from the root. And now we can come in here and do a so OS, we want to know if a file exists, right? We could do this in a couple ways. We could just do we could try an OS open file, come up with a file name, or we could just give it the full file name. Why? Just give it the full file name, right?
Mm-hmm.
So ID file. I mean, why play games? Like, we're just going to create there should be an ID.txt in there, right?
Okay.
I mean, I don't know what other extension to use other than that for now. Or call it cap ID. That feels better, doesn't it?
Cap.id.
Yeah, use it an ID extension.
Oh, okay.
Right? And we can create anything we want. So ID file now already has the full path we're expecting, right? So that simplifies this because we could just say cfg dot nats.id file. I don't have to do anything more. Now, a couple things can happen, okay? If error doesn't equal nil, then we know that the file didn't exist
Yeah.
or we have a problem. Now, there is a way of seeing if a file exists. Let's ask this. How do I check if a file exists? I never remember. It's a weird like file info call. Oh, OS stat. Right.
Returns. Yeah. OS stat returns a OS stat file info.
Yeah. So
Okay.
you get a file info. Oh, and then you do this, huh? Okay, so that's a return. All right, return from whatever. I don't know what to put there yet. Oops. Let me just see this code for a second. So we don't need the file info. So ID file check returns a boot indicating whether the argument is known to report that the file directory does not exist. So we need the error then to do that check, don't we? Okay. Now is not exists true, then we want to do an os dot create file using the same
Okay.
nats. Okay. This is also going to return an error. Oh, this should also give us a file. Yeah. And we now have the file there. So now what we can do is basically f.write string do uid dot new string. They have a new string function, by the way. So obviously, you know me and my editor.
Did an import.
Yeah, we don't get along. I feel bad for any new Go developers that have to deal with that all the day. So look, we write,
Yeah.
and then we can just close it. I want to close it right away. Now, we could check for an error here too.
That would mean that the write failed, or yeah.
Right.
Crap.
But now what's nice is after this, okay, now we just do an open. All right. We do an open. I'm going to put all this in its own section.
Yeah. Cap ID. Yeah.
And then we just have to get the ID. So the cap ID will be f dot. How do I read? I can read. So I can give it a slice of a certain length, and it will do that. But I have the probably better to do an io dot read all, giving it f, and getting back the bytes, right? That could fail too. ID read. And then our ID ends up being that, essentially. And now we pass in our ID. Oh, but it's got to be a UUID, right? Cap ID. So now we have to do a parse. I'm moving faster than it. It wouldn't be bad to log it either, would it? Now that I think about it. So look at all this code we have to write. Cap ID. Check if it exists. If it doesn't exist, create the file.
Yeah.
Then write to it, and then close it. Now we can open it, because it's nice to just be able to go down this path without an else clause.
Yeah.
So we open it, we read it, we parse it, and this messaging is bad. So how have we been doing any other logging in here? Yeah. So I could do that. Let's just do this.
Creating.
Okay, so now we've got a unique cap ID when we start that. And now we can use the cap ID here. And we keep it in the UID format.
Yeah.
Okay, let me start the server and see what happens. We've got a Zorf folder. Now, one thing we're going to have to do in here is cap ID. We can't store the zarf cap ID there. Now, I'm also concerned that if the zarf folder doesn't exist, will it create it? See, the directory containing the file must already exist. And I can't assume that it's gonna already exist.
But it should already exist.
Not necessarily. And there's no reason to have a folder in the repo if there's no file in it. So what we might have to do is an os dot. How do you create a path? Oh, there it is.
Make directory. A directory named path. So it would be zar.
Yeah, I mean, we shouldn't be hard coding that, right? What we want is everything minus, damn it. So to do this right, now, I'm gonna do this. Okay, ID file path. So let's come back in here. We're looking to see if the, okay. So you never know if somebody's going to put a / at the end of that. That's always a nightmare.
Okay.
So there's a little trick that I would use, and I don't remember it. Strings dot there's a way of looking to see if has suffix. So we've got ID file path, right?
Mm-hmm.
I want to know if it ends in this.
Okay.
Does it have this suffix, right? And then I'm going to say if that's false, then even that's fine, right? I mean, I can do that for now. That's fine, okay? Just to add it, that way I always know it's there. Because if not, then you can't form good quality paths.
Okay.
So you shouldn't assume when you're asking for a path if that's there or not. So we can check. And then if it's not there, we add it. So now we have a guarantee that it's there. And so now what we have is essentially this plus cap ID. We can hard code that, right? We can say we expect to have a cap ID there. You just tell us where you think it's going to be.
Got it. Okay.
Now, my problem here is this could fail, right? That's fine. We check to see if it didn't exist. If it doesn't exist, it doesn't mean that there is it doesn't necessarily mean there's no zar file folder.
It could mean that the directory
It
doesn't
just means
exist.
the file doesn't exist. And so now what I want to do,
Oh, sorry.
right? I can just say make directory. Now, I don't know what mode defines file mode bits. This always gets crazy to me when I got to start setting. Yeah, I never know what bits to use, dude. Like this is setting like mode and stuff. So, you know, mode perm, mode. I have no idea, man. Let's just go mode perm and see what happens. Now look, do I particularly care if that fails? I don't know. Do I really care? I mean, the next thing's gonna fail anyway. isn't it?
Yeah.
So I don't particularly care if it fails. I'm going to assume that I'm going to do it, and if it's there already, whatever. If not, it does it, and then we should be able to create everything. So let's try this code out. Okay, let's try this code out. It's real easy to try. Just going to do this. Boom. So ID file check said no such file.
ID file check.
Oh, so this failed as a check. So that's weird because I expected to have to use this. So I think what we're doing is getting rid of all this. This is where we didn't get good information from the chat, did we? Let's try that. Okay, it started up, and there's our cap ID. And we now have a ZAR folder for the cap ID.
Okay, so simpler.
So that worked. So now we have a cap ID. Now in git ignore again.
ZAR cap ID.
Oh, but this has to be
Chat.
Good. All right. So we don't do that. So now we have the unique ID and we save it. So the next time I run, it should find the same cap ID. Okay, let's push this code up and see if you get a cap ID.
Okay.
Now. All right. So let's see.
Chat run, getting cap ID.
And you should have the file. Not that anybody can see that, but you should have a file.
Yeah,
okay.
I have the file.
So now anybody that pulls this down and starts it will end up with get a unique cap ID. So now, essentially, if we do the, make chat run.
Make chat run.
Okay. And you run your hack and you say hello. Okay. Now you see that ID that's there? Oh, that's for the client, so that's fine.
That's
Hello. Yeah, no, we got to do that.
okay.
And you got it back too. Now, let's look at the logging for a second.
Cap.
So, message received, hello Bill, right? From 2. Then I sent a message over the bus. Let's do this again. Hold on. I didn't mean to kill it. All right. Send me a message. Okay. So, message from there. Hi there. Oh, I wasn't connected. So,
Yeah.
but 2 bad things happened, I think. I wasn't connected, right? So the message was received. User not found. Oh. The user was not found. Let's go look at our ACK. The ACK should have taken place because we're doing it here, right? So you sent in a message, it said user not found. Oh, did somebody else connect?
Yes. I think it was someone else. Maybe hi there. User not found.
Oh, somebody else connected. So they're that's bad. That's timeout there. I'm afraid that it was you though. I'm just gonna go small for a second. Okay, you see that we're getting this Nats timeout? I think there's a couple things going on there. So bus message received, bus retrieve, user not found. I want to find that. Okay, there's a couple things going on there. This is timing out. It's timing out
Yeah.
auto-magically. So I think we're going to have to set a real timeout here because it's got a default timeout. If not provided, 30 seconds will be used. So in 30 seconds, what's happening is this is timing out. Okay, and there's no way to stop that unless I told it to wait for forever, because this API stinks in terms of it. But I don't want to rewrite a bunch of stuff here. So let's do the following. So what do we know? Time.hour times 24 hours is a day. All right. So wait here for 24 hours for that next message.
Okay.
Now, the other option, however, is and it doesn't necessarily hurt either. What if we did time.second? Now, if there's an error, we know that it's going to be if errors is nats timeout, which I'm assuming that's what it is.
Mm-hmm.
If it's a nats timeout, then what I would prefer we do is stay here, right? Not return back to read, but we sort of stay here. Because what that will also do then is the following. I go into a loop.
Okay.
If it's a nats timeout, then just continue. Go back and try again. Okay. If it's not a nats timeout, do this and break. Or we do this and break out of the loop. Now, what's also nice about this is if the context has an error, okay, then right, that means the context timed out. We can also just return that error, say and break. So it gives us the ability then, because we don't have a context to sort of play with here, to do that. Now, what's also interesting, since we have a context here, is there's a way of getting the current deadline on this context. So I think if we go to the connect for code, let's go to the connect for code where we have the SQL stuff.
Okay.
I have code in there for business SDK here. So here's a status check. I was afraid that somebody might return an empty context, and I didn't want to wait forever on this. So let me close this here. So one of the things that I did is I said, if the context doesn't have a deadline,
Okay.
then we're going to create the deadline. But you see, what we're getting here is time when this thing is supposed to be. Now, one could argue that we could take now minus that, and we would know exactly how long that person wants us to sort of wait for the next message, which in our case, I think was an empty context anyway. So I think I'm overcomplicating it. I was going to steal the timeout from the context and then use it here,
Okay.
right? Like if somebody properly said it. But if they don't, we need to set a time anyway. So let's just say we're polling every 5 seconds. Every 5 seconds, we're polling. If it times out, we check to see, well, was that just a timeout? If it did time out, then we just come back, do it again.
Got it. Okay.
Now,
Yeah.
if it was a different error, then we'll just return that error. If the context actually timed out, which could happen, let's say maybe if somebody's trying to shut down, then we'll also die, and then we'll just come back, and then we break because they call this again. So the only time we stay in this loop is when we're doing these 5 second sort of loops here. 5 seconds is good for shutdown too. So you see what I'm doing?
Yeah.
I'm just, because this is the way this thing polls, we're there. Now, let's go back to our logs for a second. So you see how this is happening?
Yeah.
So now, if I restart this, that should stop. Now, send me a message again. Because we're still getting the other error and I don't understand it. Okay. Testing bill, user not found, one time. That's fair. That's what I expect to see. We got it. Whatever. Now, I'm gonna connect. This is perfect, right? Testing bill, I got it back.
Yeah.
Hello, Kevin. Good. Ooh, okay. Oh yeah, user not found, sending over the bus. That's what I want to see. So, message received locally, right? Local connection. User not found, sending over the bus, and then you got it. And then if I hit Control C, that's a beautiful shutdown. Okay, so fixing, and we don't see that
Yeah,
error
we
anymore,
don't have
right?
that.
And everything was working. So fixed polling, fixed nats polling. Now we don't. If we use the other API that he has, then they handle all that for us. They call. Essentially, we could register this function, right, and have them just sort of call it.
Got it.
But I hate asynchronous stuff like that because I feel like I lose. We're already sort of in an asynchronous situation with listen bus, right? Listen bus is in this here. So all of this, essentially all this code probably could be put into, yeah. Let's just look at it for 1 second. So when we set up nats here, I think it was under the consumer, right? Consume. So the consume says, write me a function that looks like this, okay? I don't, IntelliSense isn't working, so I don't know what that looks like. Okay. So it's just a function that takes a message.
Okay.
So watch this for a second. So this is listen bus, right?
Yeah.
Function listen bus 2. And in this case, why did you do that? Stop trying to help me for a second. Oh, man. It's doing crazy shit. So in this case, and this would have been, This would have been a Jetstream message too, by the way. So on listen bus 2, given a Jetstream message, we return. Context. Okay, we do it this way. Hold on. This can return a function that takes a Jetstream message. So watch this little trick. I'm not doing this right, but we're going to get it right in a second. I need this to take a context, okay?
Okay.
So I need this to take a context. So if I write this right now for a second,
Okay.
it returns a function. Returns a
Yeah.
function that has the signature we need.
Mm-hmm.
And it's a function that is this function wrapped around this context. So I'll have a unique ID instead of zeros in all the logging.
Okay.
And then given this message, this was a continue. Why did we do a continue there? Oh, because we had to go back from the beginning. But that's okay. That's a return. Yeah. So this is listen bus 2, okay?
Mm-hmm.
But I need to return a, we could probably put this all together in one thing. So hold on. Stop trying to help me. Okay. No, I don't need a context. I don't need a message. So listen bus 2, what it will do is return a function that we can apply to that other handler. So when a message comes in, the idea is that it tries to do all this,
Mm-hmm.
okay, which would replace us polling,
Got it.
as polling that we're, oh wait, that's not our problem, really wasn't the polling. Where were we doing? Hold on. Let's come back here for a second. C1 dot consume. I gotta do this after. C dot listen bus 2. So that would stop us needing this, one would argue. I'm gonna stop that. So I'm gonna tell, we're gonna try it again. I'm gonna tell the consumer, call this function
Okay.
every time a message comes in.
Got it.
Now, I want to know what the pull options are because I only want to process one message at a time. So, Jetstream. Consumer. It has to return a pull consumption option. This is the worst part about NATS, man. What I'm afraid is that I don't want it to be like messages coming in and it's just throwing go routines at it. I'd prefer that it did one at a time.
Got it. Okay. And then that's the purpose of what we're doing now.
I think. Okay, that's it right here. Oh, I had it, man. Pull. Damn it, I had it. Pull. Max. Pull max. Messages. So look at this. I'm just going to tell it to do one at a time for now because I don't want it to be out of sync.
Okay.
I don't think we need, right now we just did one at a time anyway. So look, if we do this, if this works, okay, then all this concurrency we wrote, if this works, that's it, given a message, do all this, right? That means that all this read message bus, listen, in other words,
All that can be gone.
all this can go away because we just took that. And all this that we just did with the polling
Okay. Got it.
sort of goes away because they're handling it now on their end, assuming they're doing it right. You know what I'm saying?
Okay.
I'm not going to push this, but,
Yeah.
and then if I just say, we do one at a time, it should be fine. So, and that simplifies this tremendously because now we just have to write the code for what to do when a message comes in. Because of logging, I really want this to have a unique ID every time.
Mm-hmm.
And it does. So that's good. And we just got rid of the polling. We got rid of the extra loops.
A lot of complexity is gone.
If this works. So if I do chat run and you can bring up your chat and you can send me a message, and if it works, great. Okay, so I got it.
Yep.
User not found, sending over bus, and then send me a message back. So you see all that work that we did for the concurrency and all that. I mean, it was good. Okay. And I'm glad we coded it. But now, a little smaller a second. But now that they have the ability to just add a handler,
Yeah.
that when a message comes in and we can do these options, they're handling the concurrency for us. Now all that code, we got rid of a bunch of code.
Yeah.
And now we just do this listen bus. And you can see that I had the same ID, whatever it ends up being, C for this run, which tells me that it's on that particular sort of thread. That's why I did this.
Got it. Okay.
But you see how we have a function that returns a function.
Yeah.
Yeah, so we can close over a context that isn't part of that parameter. So this is a really powerful construct here because we needed this to have a context and really couldn't pass it in.
Okay.
And then when we call the function here, listen bus, which returns the function that it needs for the consumer side. So now everything is pretty simple with this. our handshake. We have our listen loop, but the other side blocks on that. There's nothing we can do here. Now, the consumer has the read message, right? Well, when we, oh, no, you read a message. Let's look at read message again real quick.
Okay.
That's a for loop, that's fine. But we wrote this code again, right?
Yeah.
Now, in this case, we're actually reading messages from the, oh no, that's not it. That's not a NATS thing. That's a socket.
Yeah, yeah.
So that is what that is. Reading messages off of NATS is what we just dealt with.
Yes.
Okay, so I don't think we can add or reduce any more sort of complexity, right? All right, get status, get commit minus IM, using NATS, consumer code. I mean, all that concurrency was fun to write, I guess, but
Yeah.
we just got rid of like 40 lines of code,
More.
complex code.
More, yeah.
For
It's
this.
a lot more simple.
Yeah, and that's good, right? That's a sign of a good package API. So the 2 hours are up, but we've got a clean NATS sort of implementation now. So
Let's write some notes.
let's write some notes here. That was really good having Dave on. We wouldn't have ever gotten that close to what we needed.
Yeah.
So the next step is we have to.
We've been putting it off, but we have to refactor.
We have to, because after we refactor the client, I want to do decentralized authentication. And we'll talk about that next week and sort of what that means, right? Because right now we have this really nice, I'm going to argue that it's a decentralized distributed system, thanks to NATS, right? We had that conversation with, oops, hold on. Every time I want to switch, I'm on the wrong screen here. Yeah. We had this great conversation with Dave about how NATS could have clusters of NATS, and I'll diagram some of that stuff too, right? So we currently have this great distributed, decentralized sort of system.
Yeah.
We saw people already on the thing that were bringing up their own cap, and it's a mess because our client can't see that.
Yeah.
And if we're going to have a really good client, we need authentication. But if we go ahead and create a database and a user system and all that, we're no longer decentralized. We're now centralized again. I want to make it where no one person can bring down the chat network. No one person owns it.
Got it.
Okay. So anybody can bring up a NATS and connect their NATS to other NATSs. We're not going to do that here, but we know in theory we can do it. Anybody can bring up a cat and connect to any of those NAT systems. But the next stuff is basically how does somebody identify who they are in the network and that nobody can impersonate them without a user database. So this is where, after we refactor the client on Tuesday, which you probably need the 2 hours to do, we're going to talk about how we can leverage Web3 concepts to do decentralized authentication. I've got code in the blockchain project for all that. It's been a while since I looked at it, so I'm going to stumble, but we'll have decentralized authentication hopefully, if not by Thursday, the week after, and then we can deal with the last thing that I wanted to deal with,
Which was
I
encryption,
think.
right?
And then we can do encryption, but that would have to be peer-to-peer encryption. So given a session between two people, they can go into encryption mode by sharing with each other their public keys.
Got it. Okay.
Right?
Yeah.
I share my public key with you, you share your public key with me. And so now I write a message and I send it to you, and only your private key can decrypt it.
That'll be cool. Yeah.
But we need these other things in place before we do that. So we're getting close. I would say right now, with NATS, the chat server is in a really good place, and we know that. So got a couple more weeks, man. But when we get that stuff done, it's gonna be scary bad. So it's gonna be cool. All right, and that's fine, Joe. So that was you. But when we're gonna rewrite the new refactor the client using a terminal-based packages I have will still code as well, and it should be cool. So we did our 2 hours, man.
We did.
All right, so we'll see everybody again on Tuesday, and hopefully if you're looking at Nats before, you're looking at Nats a little bit stronger.
Yeah.
All right, bye.